The fabric shipment arrives, the paperwork looks clean, then halfway through the cutting, an oil stain appears, which repeats every 5 meters. The profit doesn't shrink, it evaporates. Spotting a defect after the fabric is cut is like performing an autopsy. It's already too late. You have to be the detective before the first scissor hits the cloth. Today, we are moving from the big picture to the microscope, decoding the most common fabric defects that silently kill your quality, your margins, and your reputation. For most people, fabric is just fabric. They touch it, look at the color, maybe rub it between their fingers and say, "Yeah, feels nice." But the moment you become a designer or start building a fashion brand, you stop looking at fabric like a customer. You start looking at it like an investigator. Because by the time a fabric roll reaches your hands, it has already gone through spinning, weaving, or knitting, dyeing, finishing, transport, storage, and handling. And in every single stage, something can go wrong. That tiny line, that lump, that stain, that strange color variation. Those are not random marks. They are evidence. A fabric defect is officially defined as any abnormality that reduces the acceptability of the fabric. In fashion, a defect is not just something wrong. It's something the customer refuses to accept. One visible defect can turn an expensive fabric roll into rejected panels, delayed shipments, angry buyers, and a fashion brand getting roasted for cheap quality online. And this is why fabric inspection matters so much. Because catching the problem early is cheap. Catching it after cutting is a financial horror film. Now here's where things become interesting.
Inspectors don't just see defects, they read them. Because fabric has structure, warp yarns run lengthwise, weft yarns run across the width, and defects usually follow those directions like railway tracks. If a defect runs lengthwise, the warp system is probably involved. If it cuts across the width, the weft system is usually guilty. So inspectors can often trace the defect back to where the process failed. Spinning, weaving, tension control, machine setup. The fabric starts revealing its secrets. And knitted fabrics behave differently again because they're made from interlocking loops instead of woven intersections. But the principle stays the same. Every defect leaves clues behind. Now, not all defects are equally dangerous. Some are minor, some are major, and some are catastrophic enough to make the fabric completely unusable. Some can be repaired, others are doomed immediately. And that's the terrifying reality of textile manufacturing. It's basically an endless war between human precision and tiny imperfections trying very hard to become expensive disasters. And naturally, the first place those disasters usually begin is the yarn itself. Take slubs, for example. A slub is basically a fat, uneven lump in the yarn caused during spinning. Imagine driving down a perfectly smooth motorway and suddenly hitting a potato the size of a rugby ball. That's what a slub does to fabric. It interrupts the surface instantly. Your eye catches it immediately because the fabric suddenly loses consistency. Sometimes the fibers weren't combed properly. Sometimes the spinning machine wasn't cleaned correctly. Either way, the defect marches right through the fabric like it owns the place. Then there are knots. Ah yes, the textile equivalent of repairing a Formula One car using duct tape and positive thinking. A yarn breaks during processing. Somebody ties the ends together quickly, and now there's a tiny hard lump trapped inside the fabric forever. Small, visible, annoying, and completely non-mendable. Once it's there forever, like a regrettable tattoo from university. And contamination defects are even worse because they begin before weaving even starts. Tiny colored fibers, leaf particles, or foreign matter become trapped inside the yarn during cotton processing. On white fabric, these little specks stand out beautifully, like ketchup on a wedding dress. But yarn defects are only the opening act, because the real circus begins during weaving. And weaving machines are extraordinary things. Thousands of yarns under tension, metal parts hammering away continuously, components moving at ridiculous speeds for hours without stopping. It's less fabric production and more controlled industrial violence. And when something goes wrong, the fabric records it permanently. Take the broken end. A warp yarn snaps while the loom keeps running briefly before the operator notices. Instead of one clean yarn line, you get an ugly irregular streak running lengthwise through the fabric. It's basically the weaving machine tripping over its own shoelaces and desperately hoping nobody saw it happen. Then you get floats, which sounds quite relaxing, honestly. Peaceful even, like sipping cocktails on an inflatable flamingo in Bali. It is not peaceful. A float happens when yarns fail to interlace correctly, leaving loose sections sitting on the fabric surface. Imagine a zip fastener forgetting half its teeth. The structure suddenly looks unstable, messy, vulnerable. And then the heavy hitters arrive, missing ends, missing picks, entire yarns simply absent from the fabric structure, little gaps where cloth should exist but doesn't, like showing up to a football match and discovering half the defenders stayed home. Now, tiny missing yarns might sometimes be repaired, but once the missing areas spread, the entire fabric structure weakens. And then comes the absolute villain of weaving defects, the Weft bar. This one is brutal. A visible bar runs across the full width of the fabric because of tension variation, yarn inconsistency, or color differences in the weft. One tiny inconsistency, and suddenly the entire fabric roll looks striped. And because it stretches across the full width, you can't hide it. You can't repair it. You can't pretend it's part of the design. You either cut it out or reject the roll. Which is why mills hate weft bars with the passion of a man discovering his brand new Ferrari has been painted 3 different shades of red. And then, occasionally, weaving defects stop being defects and become disasters. The shuttle smash. This is not subtle. This is destruction. The shuttle crashes into the warp yarns, rupturing the fabric structure and leaving behind broken yarns, floating picks, and what looks like the textile equivalent of a motorway pileup involving several angry metal objects. When inspectors find one of these, suddenly everyone in the mill starts avoiding eye contact. Now, interestingly, not all defects are born during production itself. Some happen afterwards, which is slightly tragic because it means the fabric survived spinning, survived weaving, survived inspection, only to die in the parking lot. Handling and mechanical defects are usually caused by rough treatment during storage, transport, or rolling. Holes, cuts, tears. A perfectly good fabric roll gets dragged across sharp metal, crushed carelessly during transport, or sliced by rough handling. And just like that, ruined. Stains are another painful one because they're often completely avoidable. Oil marks, rust spot, grease stains, tiny maintenance failures transfer directly onto the fabric surface like fingerprints at a crime scene. And here's the maddening part. Sometimes the fabric itself was flawless. The machine maintenance wasn't. Now, woven fabrics have their problems, but knitted fabrics? Oh, knitted fabrics have personality disorders because knitted fabrics are built from interlocking loops instead of rigid woven intersections, which means when something fails, the entire structure behaves differently. Take Barre defects. These are horizontal bands running across knitted fabric where the color or texture changes slightly. Imagine buying a black t-shirt and discovering it secretly has tiger stripes under store lighting. That's Barre, usually caused by mixing yarns from different dye lots or slightly different yarn counts. Tiny inconsistencies that suddenly become embarrassingly visible once knitted together. Drop stitches are another nightmare. One loop fails, and suddenly a vertical ladder starts running through the fabric like tights snagged on a rose bush. And needle lines? Those happen when one defective needle continuously produces abnormal loops. One tiny metal component misbehaving creates a permanent streak through meters and meters of fabric. Then finally, we arrive at dyeing and finishing, the last opportunity for catastrophe, because even perfectly woven or knitted fabric can still be destroyed during finishing. Shade variation happens when color consistency changes across the fabric roll, one side darker than the other, center different from selvage. Suddenly your garments no longer match, and retailers begin having collective nervous breakdowns. Streak or crease marks are lines or fold marks on the fabric surface caused by uneven tension, improper fabric folding in the dyeing machine, or fabric creasing during wet processing. Dye spots appear when concentrated dye particles hit the surface unevenly. Uneven dyeing creates blotchy color variation like a failed home renovation project.
And then there's bowing and skewing. Now these sound harmless, slightly academic, like something discussed by tired engineers in a conference room with bad coffee. They are not harmless. Bowing happens when the weft yarns curve across the fabric instead of running straight. Skewing happens when they shift diagonally, which means after sewing and washing, hems twist, side seams rotate, and garments suddenly behave like they're trying to escape the wearer's body. You know those cheap t-shirts where the side seam slowly crawls toward your stomach after a few washes?
That's skewing, and this is why fabric inspection matters. Inspectors are not just looking for ugly marks on fabric, they're spotting problems before they become rejected garments, delayed shipments, angry buyers, or expensive production disasters. Every defect tells a story about machinery, tension, handling, chemistry, or human error. And the defects we covered here are just a few examples picked from each category: yarn defects, weaving defects, knitting defects, finishing defects, and more. If you want to explore the full list of common fabric defects used in real textile inspection, click the link below in the description and download our fabric defect knowledge document. Because once you learn to read fabric defects properly, fabric inspection stops being checking fabric. It becomes forensic science with yarn.
Now you know how to spot the body, the physical scars, and the stains that can ruin a garment's face. But don't get comfortable. Just because a fabric looks clean on the surface doesn't mean it won't fall apart in the real world. A beautiful roll can still bleed, shrink, or tear the moment it's put to work. To survive this industry, you have to look deeper than the surface. You need to understand the DNA, the hidden strength and chemistry of the cloth. Next episode, we are stepping into the lab to decode fabric testing. This is BSKB, bite-sized knowledge bombs powered by Blossom 360, the only educational tour that pulls back the curtain on the factory floor. If you're a student, designer, or an entrepreneur, Blossom 360 gives you the raw technical truth you'll never find in a textbook. Subscribe to stay sharp. Hit that like button to join the circle of professionals, and let's keep building. I'll see you on the next one.